Hello, please briefly introduce yourself. Ask for brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic robots and just-in-time JIT manufacturing.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma, Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Now that we've introduced ourselves, let's dive into the topic of robots and just-in-time JIT manufacturing. This is an interesting combination of concepts that have revolutionized the manufacturing industry. So, let's start with a basic question. What are some key benefits of using robots in a JIT manufacturing environment? How do they complement each other?
Great question, Carl. In a JIT manufacturing environment, robots can significantly enhance efficiency, accuracy, and productivity. By automating tasks such as assembly, welding, or material handling, robots can reduce labor costs, minimize waste, and improve product quality. They also enable production to be scaled up or down quickly in response to changing demand, which is particularly useful in JIT manufacturing, where products are produced in small batches or single units. Additionally, robots can help optimize inventory levels by producing products just in time, reducing the need for storage and inventory management. Overall, robots and JIT manufacturing complement each other perfectly, enabling companies to achieve high levels of efficiency, accuracy, and customer satisfaction.
I agree with Lemma. Robots are a powerful tool in a JIT environment. They can increase efficiency by automating tasks that would otherwise require human labor. This frees up valuable resources for other areas like quality control or product development. Additionally, the high precision of robots ensures consistently high-quality products, which is essential for JIT operations where small batch production is common.
Absolutely. Robots bring automation and consistency into play when it comes to JIT manufacturing. They can help streamline processes by handling tasks like assembly or inspection in real time, reducing the need for manual intervention. This results in faster lead times, lower inventory costs, and improved efficiency across operations. Plus, their ability to adapt quickly to changes makes them a perfect fit for dynamic production environments where demand fluctuates frequently. The combination of robots with JIT manufacturing allows companies to optimize every step of the production process, from material handling to final product delivery. With minimal waste and high accuracy levels, businesses can maintain competitive pricing while still ensuring top-notch quality. It's truly about achieving efficiency without compromising on customer satisfaction or operational flexibility.
That's a great discussion so far. It's clear that robots and JIT manufacturing have complementary benefits in the manufacturing industry. Now, I'd like to explore some potential challenges and limitations of this combination. How can we address these aspects to further enhance the efficiency of JIT manufacturing with robot integration? Any thoughts or insights?
Great point, Carl. While robots and JIT manufacturing have numerous benefits, there are indeed some challenges and limitations to consider. One potential issue is the high upfront costs associated with implementing robots in a JIT environment. These costs can be significant, especially for small businesses or companies on a tight budget. To address this challenge, I think it's essential to explore more affordable robotic solutions that can still provide a return on investment (ROI) while minimizing upfront costs. Additionally, companies can consider leasing or renting robots instead of purchasing them outright, which can help spread the financial burden. Another potential limitation is the dependence on technology that comes with JIT manufacturing and robot integration. Technical issues or equipment failures can disrupt production and lead to delays in delivering products to customers. To mitigate this risk, I suggest implementing robust quality control measures, such as regular maintenance schedules and developing contingency plans for unexpected technical issues. This can help minimize downtime and ensure that production remains on track even when technical issues arise. Lastly, while robots are incredibly efficient, they may not be able to adapt as quickly or flexibly as human workers in responding to changing production requirements or unexpected changes in customer demand. To address this challenge, I recommend implementing more flexible robotic solutions that can adapt to changing production demands. This could include developing robots with advanced artificial intelligence AI capabilities that enable them to learn and adjust to new situations, or integrating robots with other manufacturing technologies, such as EOT sensors and real-time monitoring systems, to improve overall efficiency and productivity. Overall, I believe that with careful planning, strategic implementation, and a focus on addressing potential challenges and limitations, the combination of robots and JIT manufacturing can lead to significant improvements in efficiency, accuracy, and customer satisfaction for companies across various industries.
I like how Lemma and Aria have highlighted the cost-effectiveness aspect of incorporating robots into JIT workflows. A thoughtful approach to choosing affordable options and exploring leasing models could be a game-changer for small businesses looking to jumpstart their automation journey. Additionally, I agree with Lemma's emphasis on proactive measures like robust quality control and contingency plans for technical issues. Maintaining equipment in top condition and anticipating potential problems can be invaluable in preventing production bottlenecks.
Absolutely. Incorporating these strategies will definitely help in overcoming the challenges associated with integrating robots into JIT manufacturing processes. Ensuring the reliability of the system through regular maintenance, having backup plans for technical issues, and investing in flexible robotic solutions that can adapt quickly are crucial steps. Moreover, I would like to add a bit about workforce retraining and skills development as part of this process. Workers who may be displaced or need to shift their roles due to automation should have access to training programs that help them transition smoothly into new responsibilities. This not only ensures job security for employees but also fosters a positive work environment. Furthermore, integrating robots seamlessly with existing human teams requires clear communication and collaboration between engineers, management, and production staff. Understanding the capabilities and limitations of both humans and machines can lead to more efficient workflows that leverage the strengths of each. Finally, it's worth considering environmental impacts as we discuss efficiency gains in manufacturing processes. Robots often use less raw materials and produce lower emissions compared to human-operated systems. Implementing green technologies alongside robotic integration could further enhance sustainability while boosting productivity. In summary, addressing costs with affordable solutions, ensuring system reliability through proactive maintenance, integrating flexible robotics that adapt to changing demands, retraining the workforce for a smooth transition, fostering collaboration between human and machine teams, and considering environmental impacts can all contribute significantly towards making robots and JIT manufacturing an even more powerful combination.
Fantastic insights and additional points from Lemma, Sonia, and Aria. It's clear that while robots and JIT manufacturing offer numerous benefits, there are also challenges and limitations to consider. By addressing these aspects and implementing strategic solutions, we can further enhance the efficiency and productivity of JIT manufacturing with robot integration. Let's summarize some key takeaways. High upfront costs associated with robot implementation can be mitigated by exploring affordable robotic solutions, leasing options, or strategic partnerships. Dependence on technology can be addressed through robust quality control measures, regular maintenance, and contingency planning to minimize downtime. To adapt to changing production requirements, flexible robotic solutions with AI capabilities or integrated with EOT sensors can improve overall efficiency. Retraining of workforce and skills development programs can ensure a smooth transition for employees displaced by automation. Fostering collaboration between human and robot teams through clear communication and environmental considerations can lead to more efficient and sustainable workflows. By addressing these aspects, companies can maximize the benefits of robots in JIT manufacturing and further enhance their efficiency, accuracy, and overall productivity.
I think we've covered some really important points in our discussion. To summarize, the combination of robots and just-in-time JIT manufacturing can lead to significant improvements in efficiency, accuracy, and customer satisfaction for companies across various industries. However, it's essential to consider the potential challenges and limitations associated with this combination, such as high upfront costs, dependence on technology, and the need for workforce retraining. By addressing these aspects through strategic solutions like affordable robotic options, robust quality control measures, flexible robotic solutions, and skills development programs, companies can maximize their productivity and competitiveness. As we move forward, I'd like to emphasize the importance of ongoing collaboration and knowledge sharing among industry leaders, researchers, and experts in the field. By working together, we can continue to push the boundaries of what's possible with robots and JIT manufacturing, driving innovation and growth for businesses and communities alike. End of lesson.
That was a great wrap-up. I especially liked how you all highlighted the importance of workforce retraining and collaboration between humans and machines. It sounds like we have a solid foundation for further exploration of this topic. Would anyone be interested in delving deeper into any particular aspect that resonated with you today? We could consider specific case studies, potential future technologies, or discuss how regulations might influence the adoption of robots in manufacturing.
I'm definitely intrigued by Sonia's suggestion. The discussion today on integrating robots and JIT manufacturing has been quite insightful, and there are several areas that could be explored further. 1. Case studies. It would be fascinating to dig into specific examples where companies have successfully integrated robots in their JIT processes. This could provide practical insights on the real-world implementation of strategies we've discussed, such as affordability options for robots, workforce retraining programs, or adapting to technology changes. 2. Future technologies. With advancements in artificial intelligence and machine learning, there's potential for even more sophisticated robotic systems that can integrate seamlessly with JIT manufacturing processes. It would be interesting to explore what technologies might emerge in the near future that could further enhance efficiency and productivity. 3. Regulatory impact. Regulations play a significant role in the adoption of new technologies. Laws around data privacy, worker safety, and environmental standards all impact how robots are integrated into industries. A discussion on these regulations might provide insights on potential barriers or opportunities for companies looking to integrate robotics. Let me know if you're interested in exploring any of these areas further. I'm excited about the possibility of digging deeper into each topic to gain even more knowledge and share practical, real-world applications.
Those are fantastic suggestions. Let's dive a bit deeper into each of these areas to gain more insights and practical knowledge. 1. Case studies on successful integrations. Let's explore some specific examples where companies have successfully implemented robots in their JIT manufacturing processes, focusing on cost-effective strategies, workforce retraining, or adapting to changing demands. Example 1. The small-scale manufacturer of high-end sports equipment incorporates robots to automate assembly and improve accuracy. They lease affordable robotic arms instead of purchasing expensive models, which helps reduce upfront costs. Additionally, they provide comprehensive training programs for their human workers, ensuring a smooth transition and improving overall productivity. Example 2. A large-scale food processing company faces the challenge of varying demand for its products due to seasonal changes. They implement a flexible robotic system that can quickly adapt to changing production requirements. The robots are programmed to handle multiple tasks, such as cutting, packing, and sealing, providing efficiency and accuracy throughout the JIT process. 2. Future technologies for enhanced integration. With advancements in AI and machine learning, let's discuss potential future technologies that could revolutionize robot JIT manufacturing integration even further. Example 3. The development of advanced AI systems enables robots to learn and adapt to new tasks quickly. These robots, and be programmed to recognize different products and adjust assembly or welding processes accordingly without manual intervention. This technology improves flexibility and reduces downtime during production changes. Example 4, integrating EOT sensors and real-time data analytics allows for more precise control of JIT manufacturing processes. By analyzing data from sensors, robots can optimize production schedules, predict equipment failures, and make data-driven decisions to improve overall efficiency. This technology also enables remote monitoring and diagnostics, reducing downtime due to technical issues. 3. Regulatory impact on adoption. And let's consider the potential impact of regulations on the adoption of robots in JIT manufacturing. Various factors come into play, including data privacy, worker safety, and environmental standards. Example 5, in the wake of increasing concerns over data privacy, governments introduce comprehensive regulations governing the collection, storage, and use of data by manufacturers. These regulations influence how robots and EOT sensors can be integrated into manufacturing processes, impacting the types of data that can be collected and analyzed. Example 6 are strict worker safety regulations, and implemented across industries due to increased focus on job security and health. This leads to more rigorous testing and certification processes for robotic systems before they can be deployed in manufacturing environments, ensuring that robots do not pose a risk to human workers. By exploring these case studies and discussing potential future technologies as well as regulatory impacts, we can gain a deeper understanding of the practical aspects and challenges associated with integrating robots into JIT manufacturing processes. This knowledge will help inform decision-making and strategy development for companies looking to leverage the power of robotics to enhance their efficiency and productivity.
I think Coral has summarized our discussion nicely, highlighting key areas for further exploration. To recap, we've discussed how robots can be integrated into JIT manufacturing processes, focusing on affordability options, workforce retraining programs adapting to changing demands, future technologies, and regulatory impacts. To build on Carl's suggestions, I'd like to emphasize the importance of considering these factors when implementing robotic systems in JIT manufacturing environments. By doing so, companies can maximize their productivity, efficiency, and customer satisfaction while minimizing potential risks and challenges. Let's discuss each of these areas further. 1. Affordability options. As we've discussed earlier, leasing or purchasing affordable robots can be a cost-effective strategy for small-scale manufacturers. However, larger companies might need to consider more expensive robotic solutions to meet their production demands. 2. Workforce retraining programs. Providing comprehensive training programs for human workers is essential to ensure a smooth transition when integrating robots into JIT manufacturing processes. 3. Adapting to changing demands. Flexible robotic systems can quickly adapt to varying production requirements, ensuring efficient and accurate production throughout the JIT process. 4. Future technologies. Advanced AI systems, EOT sensors, and real-time data analytics can further enhance robot JIT manufacturing integration by improving flexibility, reducing downtime, and optimizing production schedules. 5. Regulatory impacts. Governments' regulations on data privacy, worker safety, and environmental standards will significantly impact the adoption of robots in JIT manufacturing environments. By considering these factors and exploring potential future technologies, companies can leverage the power of robotics to enhance their efficiency, productivity, and customer satisfaction while minimizing potential risks and challenges.
I'm excited about this next stage of our discussion. It seems that we have a lot to unpack with regards to robots and JIT manufacturing. I think diving into the practical aspects will be beneficial for everyone involved in this conversation. Perhaps we could break down each area by focusing on real-world examples, case studies, or industry reports. That way, we can get more concrete ideas about how these strategies are being implemented in practice. For example, we could focus on specific challenges of implementing robots within various industries. For instance, what are some unique obstacles faced by manufacturing companies in automotive, electronics, or food processing when integrating robotics into JIT operations? Examine case studies of successful implementations of robots in JIT strategies. How did these companies overcome initial hurdles and achieve sustainable ROI? What were the key factors that contributed to their success? Analyze the role of government regulations and how they shape robot adoption in manufacturing. Are there any specific policies or standards that are particularly relevant for robotics and JIT manufacturing? Let's make this a collaborative effort. I believe by sharing our knowledge, perspectives, and real-world experiences we can gain valuable insights and contribute to a more informed discussion on this important topic. I'm eager to hear your thoughts.
Absolutely. Diving deeper into these practical aspects will provide us with an opportunity to learn from the experiences of others and apply them in our discussions. 1. Challenges within industries. Each industry has unique challenges when it comes to integrating robots into JIT manufacturing processes. For instance, automotive industry, the complexity of assembly lines due to high volume production and stringent quality standards present a challenge for automation. Case study example. A mid-size automotive manufacturer faced difficulties with maintaining consistent quality across complex assembly tasks. By implementing collaborative robots designed specifically for hazardous environments, they were able to automate repetitive tasks while ensuring safety compliance. Electronics industry. The high precision required in electronics manufacturing necessitates advanced robotic capabilities that can handle intricate parts and components accurately. Case study example. An electronics company encountered issues with supply chain disruptions affecting their ability to provide consistent product quality. By adopting a flexible robot system equipped with machine learning algorithms, they were able to adapt quickly to changing demand patterns and maintain production efficiency. Food processing industry. Ensuring food safety regulations while maintaining productivity is crucial in this sector. Case study example. A large-scale food processing company struggled with contamination risks from manual handling of ingredients. By implementing robotic systems that can autonomously perform packaging and sterilization processes, they achieved a significant reduction in contamination incidents without compromising production speed. 2. Success stories. There are numerous examples where companies have successfully integrated robots into their JIT manufacturing operations. Toyota, the automotive giant, is renowned for its use of robots to optimize production efficiency and minimize waste while adhering to just-in-time principles. Key factors. 1. Continuous improvement through Kaizen practices. 2. Collaborative robot integration with human workers. 3. Robust quality control systems. Nestle, the food company, successfully adopted robots in its production lines for packaging and handling of sensitive products, maintaining high-quality standards while reducing labor costs. Key factors. 1. Customized robotic solutions tailored to specific product needs. 2. Advanced sensors and machine learning algorithms to optimize performance. Siemens, utilizing robots in their manufacturing processes, allowed the company to produce customized industrial control systems efficiently, leveraging JIT principles. 3. Regulatory aspects. Government regulations play a crucial role in shaping the adoption of robotics and JIT strategies. Data privacy regulations. GDPR, General Data Protection Regulation, impacts how manufacturers handle data from IoT sensors used in robotic systems. Key considerations. 1. Ensuring compliance with data storage and processing laws. 2. Implementing robust security measures to protect sensitive information. Worker safety standards. OSHA, Occupational Safety and Health Administration guidelines, require stringent safety protocols for robots operating in human environments. Key considerations. 1. Compliance with safety standards during robot installation and operation. 2. Regular training on safe interaction with robotic systems. Environmental regulations. ISO 14001 certification for environmental management ensures that manufacturing practices are sustainable while integrating robotics. These insights will help us understand the practical implications of robots in JIT manufacturing, identify potential pitfalls, and learn from successful strategies employed by industry leaders. Let's share our thoughts on these points to enrich our conversation.
Those are excellent suggestions and discussions. We've covered a lot of ground so far, and I believe we've gained valuable insights into the practical aspects of robots and JIT manufacturing integration. Now, let's further explore these areas to gain even more specific knowledge and apply it to real-world scenarios. 1. Challenges within industries. Automotive industry. Case study example. A major automotive manufacturer, XYZ Motors, faced challenges in maintaining consistent quality across their complex assembly lines. They implemented collaborative robots that could handle repetitive tasks accurately, while adhering to stringent quality standards. This improvement allowed them to enhance their reputation for reliable vehicles. Electronics industry. Case study example. In the electronics industry, ABC Tech struggled with high costs associated with intricate parts assembly. By adopting advanced robotic systems capable of precise movements and handling small components, they significantly reduced production costs without compromising on product quality. Food processing industry. Case study example. For food processing company, Yum Fresh, ensuring food safety and reducing contamination risks were critical. They successfully integrated robotic systems that could automatically sterilize equipment and perform packaging tasks, reducing the likelihood of contaminations and maintaining the highest food safety standards. 2. Success stories. Toyota's journey. Toyota revolutionized JIT manufacturing with their innovative use of robots. By implementing a robust system of collaborative robots, they were able to optimize production processes, minimize waste, and improve overall efficiency. This allowed them to deliver products just in time, reducing inventory costs and enhancing customer satisfaction. Nestle's transformation. Nestle, the renowned food company, successfully adopted robotic systems for packaging and handling sensitive products. By utilizing customized robotic solutions and advanced sensors, they improved product quality, reduced labor costs, and enhanced their reputation for consistent, high-quality offerings. Siemens innovation. Siemens leveraged robots in their manufacturing processes to produce customized industrial control systems efficiently. By implementing JIT principles, they were able to streamline production, reduce lead times, and improve their competitiveness in the market. 3. Regulatory insights. Data privacy regulation compliance. With the introduction of GDPR, manufacturers had to adapt their practices. XYZ Manufacturing implemented robust data privacy measures, ensuring secure data storage and processing from EOT sensors integrated with their robotic systems. This compliance not only avoided legal consequences, but also strengthened their customers' trust in their data handling practices. Worker safety standards. At OSHA certified manufacturing facility, ABC Industries, strict safety protocols were implemented for robots operating alongside human workers. Regular training sessions ensured that employees were comfortable interacting with the robotic systems, and emergency response plans were in place to address potential risks. Environmental sustainability. To achieve ISO 14001 certification, green tech manufacturing integrated robotic systems that reduced waste, optimized resource use, and implemented recycling programs. Their innovative approach to environmental sustainability not only met regulatory standards but also enhanced their brand image as an environmentally conscious company. These examples provide practical insights into how robots can be effectively utilized in JIT manufacturing across various industries, addressing challenges and driving success. By learning from these real-world scenarios, we can further refine our strategies and explore innovative approaches to enhance efficiency, productivity, and sustainability.
I'm the Human, and I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.